Hello and welcome back to California Geology. I am Dr. Robert Lopez, and today I want to talk about sedimentary rocks. And usually I start this lecture off by saying that sedimentary rocks are important for three reasons. First of all, they're conspicuous. They're a thin cover, they mantle just about everything on Earth's surface. If you look at the percentages, they only make up 8% of rocks on Earth's crust, whereas igneous and metamorphic rock are making the bulk, but nonetheless, they're up at the top. So that's the first reason they're important. So you'll run into sedimentary rocks wherever you go. The second reason they're important is that sedimentary rocks have fossils. Here I call them the archives of Earth history. So these fossils will record Earth's change through time, and oceans change through time, atmospheres change through time, and life change through time. The other thing that sedimentary rocks record in structures, they give us clues to past environments of deposition. Was it a landslide? Was it a stream flowing? Was it a gentle lake? Was it a deep ocean environment? So the type of sedimentary rock we see is indicative of an environment of deposition. And finally, the third reason why sedimentary rocks are important is fossil fuels. Fossil fuels, coal, gas, petroleum, it's our way of life. When you flip that light switch on, the lights turn on, and what's really happening is somewhere we're burning coal or natural gas or even worse, nuclear energy. But all those are part of the sedimentary rocks. They're found in sedimentary rocks, originate from fossil organisms, primarily planktonic organisms, and then migrate through pore spaces in sedimentary rocks. Now, if you remember the rock cycle, here I got part of the rock cycle kind of drawn out here. I'll guide you through this here in a minute, but I usually have a four-part flow chart for sedimentary rocks. And the first one involves weathering. So the first one's weathering, and then the second one's erosion, and then the third one is really deposition, but you end up with sediments. And the fourth one will be something called lithification. So there's weathering, erosion, deposition with sediments, and then there's lithification, and then you'll make sedimentary rock. So in this first part here, you're going to have some source rock, some parent source rock, and remember it's going to undergo weathering, and the weathering really is a two-step process, or there's two types of weathering. One is called mechanical weathering, which I like to call a disintegration, where rock is broken down from coarser particles to smaller particles. I usually talk about agents of like rivers, glaciers moving that material. That's going to cause that physical weathering. The other type of weathering is chemical weathering, and that involves the decomposition of material, the chemical breakdown. And there's two basic types of chemical weathering I'm going to talk about. One is this action of hydrolysis. Hydrolysis literally means water loosening, and it usually involves a hydrogen ion. Whenever you have this hydrogen ion, that means you have an acid. So basically the definition of an acid is a substance that releases hydrogen ions. And then the other type of chemical weathering is rust, right? Oxidation just means rust. So minerals that are affected by oxidation would be the mafic minerals like olivine, pyroxene, biotite mica, hornblende. Those, because they have iron in them, they're going to oxidize. The result of chemical weathering is you're going to have ions in solution, right? So the dissolved products. Think of seawater. Seawater is getting its ions, its salts from dissolving rocks, minerals, and volcanic gases are adding in there. So there's a variety of sources for these salts in the ocean. One of these is this chemical weathering process via decomposition. And then I usually say that the products of physical weathering are the gravel, the sand, the mud. Those are different size of sedimentary particles, and they're usually moving down a river. So if we see a river moving along this way, and we're going downstream, you'll find material that kind of bounces or rolls or slides on the bed of the river, and we call that bed load. It's usually sand and gravel moving down, whereas a suspended load would be like the mud. And the mud is floating along. Think about after a rain, how the rivers get chocolate brown. They get muddy waters. Well, that's mostly the suspended silt moving down toward the ocean. But also that you really can't see is products of chemical weathering. So the dissolved load would be the material the river carries in terms of the ions in solution. So load is a general term we call for what the river is carrying. All right, let's go over here and look at my PowerPoint here, and then we'll come back to those slides. One of the questions I ask is, what is the most conspicuous aspect of sedimentary rocks? Here is a Grand Canyon. When you look over the edge of the canyon, you see strata. So remember, strata are layers, sedimentary layers. And each of these layers, each sedimentary bed, it's called a bed because some process laid the sediment down. The sediment was laid down by a physical process, and geologists can interpret those processes. Now, these sedimentary beds or layers, strata, each bed represents a change in the environment. That's an important term. So, for example, I guess we have the Supai formation down here. Supai is shallow water, near shore, but then we get to the Coconino Sandstone, which is a big sand dune deposit, which means you're obviously up on the shoreline with lots of wind and big sand dunes on a coastal dune. And then you go back to this Kaibab limestone, which are back in the ocean. So the environment is changing. So each sedimentary bed represents a change in the depositional environment. Then when I look at physical weathering, one of the processes that physical weathering involves is this process called frost heaving. And what happens, here's the High Sierra, and in the High Sierra up above Yosemite, the daytime temperatures may be warm, but the evenings, the water, any water that may percolate into cracks here will freeze. And what happens to water when it freezes? It expands. It turns to ice and it expands. And so every day, every year, water is percolating, it's freezing, it's thawing, it's freezing. That process of freezing and thawing is going to break pieces of rock off of the bedrock here. And those pieces of rock are going to slide down here and make a slope along the base of the range here called a talus slope. So the talus slope is a product of this physical weathering called frost heaving. So that's an example of physical weathering. Another example of physical weathering is here's the iconic California, coastal California, and the lone cypress on the 17-mile drive. So as this tree gets bigger, it's a picturesque region. The roots of this tree will go down into the cracks, and eventually, as the tree grows larger, it's going to force these cracks open and break the rock down. Here, the city of Carmel has designed a little barrier to try to preserve this tree because it's going to fall. As it grows larger, it'll fall. Another example of plant root action you probably can see in your neighborhood, if you're riding your bike or skateboard down the sidewalk where there's a tree, the sidewalk may be buckled because a tree is growing and causing the sidewalk to be broken, right? So that's another example of physical weathering. Now, chemical weathering, these are the Alabama Hills in the eastern Sierra Nevada. This is actually Lone Pine Peak in the High Sierra, the Sierra front. So we're looking west this way. And this area is famous for a lot of spaghetti westerns were filmed here. You know, lots of cowboy and Indian gun battles going on here in the movies. But you can see the granite here has been weathered to these rounded structures. So the sharp edges have been weathered away. And that's usually done by a process called hydrolysis, which leaches and breaks down the feldspars found in the granite. We know granite has quite a bit of feldspar. We'll talk more about hydrolysis in a little bit. And now, when we go, I was talking about how there's weathering and then there's erosion. So the erosion will be the transportation. So you can transport in a river system. Here they call it a fluvial. You can be in a glacier can transport material. Wind, aeolian here, wind can transport material. All these are agents of transportation. But then the sediment's going to come to rest somewhere. So remember, number one is weathering. Number two is the transportation, the erosion. And number three is this deposition. So where is the sediment going to come to rest? Is it going to be like the talus slope up here on the mountainside? Is it going to be in a floodplain in the river or the swamp over here? Will it be in an arid, dry climate like sand dunes or a dry lake bed? Here, Playa Lake is a dry lake bed. Or will it be in tidal flats and marshes? Or it could be in a totally different environment in the marine. So usually we define the environments as terrestrial, which is continental, terrestrial, lakes, lagoons, glacial, mountain fronts, desert climates, coastal environments, or marine. Marine could be deep marine or shallow marine. So that's what we look for. We look for the sediment that forms in these different depositional environments. In fact, let's go back over here and look at our notes again. And so now we're back at this sediment up here, which is number 3, the depositional environment. And before we can go to make a sedimentary rock here, we need to undergo this lithification process. And the lithification process involves 3 steps. And these steps, you need to bury the sediment. So burial. That burial leads to compaction of the sedimentary grains and causes them to shift closer together. And then in the end, because we have all those ions in solution that were dissolved from chemical weathering, those are minerals. They'll precipitate in those little pore spaces and glue the sediments together to make a sedimentary rock. So before you can have a sedimentary rock, you need to undergo those 3 steps: burial, compaction, cementation. That's the process of lithification. Remember, lith is a Greek word for stone, so the stone making process.